It is a dark, rainy night, and Tariq is completely lost in an unfamiliar city. He pulls over in frustration. He pulls out his phone, opens his map, and instantly, a glowing blue dot finds his exact location down to the meter. But how does a tiny piece of glass and metal in your pocket know exactly where you are on planet Earth? The next day, his physics teacher, Mr. Sir, explains. The answer isn't on Earth. It is 20,000 kilometers above our heads. Your phone is secretly talking to a network of 24 global positioning system satellites orbiting the planet. But these satellites aren't just cameras. They are actually giant, incredibly precise atomic clocks flying through space. They constantly broadcast the exact time. Your phone catches this signal and calculates how long it took to arrive at the speed of light. But here is where physics throws a massive curveball. These satellites are moving at 14,000 kilometers per hour. Over a century ago, Albert Einstein realized something crazy about speed in his theory of special relativity. Einstein proved that if you move incredibly fast, time itself literally slows down for you compared to someone standing still. Because the satellite is moving so fast, its clock ticks slower than Tariq's phone, losing about 7 microseconds every day. But wait, it gets crazier. Einstein also gave us general relativity, which says that gravity literally bends space and time. Down here on Earth, gravity is strong. That strong gravity acts like a weight, dragging on time and making it tick slower. But up in space, 20,000 kilometers away, the Earth's gravity is much weaker. There is less weight dragging on the clock. Because the gravity is weaker, the satellite's clock actually runs faster than the clocks on Earth, gaining 45 microseconds a day. So, speed slows the clock down by 7, but weak gravity speeds it up by 45. The net result? The satellite clock runs exactly 38 microseconds faster every single day compared to the phone in your pocket. Tariq shrugs. 38 millionths of a second? That is completely invisible to human beings. Why does it matter? It matters because radio signals travel at the speed of light, and light travels incredibly far in just 1 microsecond. If we ignored Einstein's relativity, that tiny 38 microsecond time difference would completely destroy the GPS math. Within just one single day, your GPS location would be wrong by 11 kilometers. The app would drive you straight into a river. To fix this, engineers literally program Einstein's equations of relativity straight into the GPS software. They purposefully build the satellite clocks to tick slightly slower on Earth, so that once they hit orbit, relativity speeds them up to match perfectly. Thanks to this mathematical correction, the time in space and the time on Earth stay in absolute perfect sync. Back in the rain, Tariq's map locks in. He takes the correct turn, safely finding his way through the storm. So every time you use your map to find a coffee shop, remember, you are carrying a piece of Einstein's genius right in your pocket.